Ask my instructor 12.9.31. Find the unit tangent vector t and the principal unit normal vector n for the following parameterized curve. Verify that the length of t and the length of n are equal to 1 and that t and n are orthogonal. The only thing I'm not going to do is this last piece, that t dot n is equal to 0. I'll leave that up to you. I think by the time we get there, you'll know exactly what to do. This problem was sent to me not because it's intellectually difficult, but because it's very hard to keep track of the details, and I'm hoping to be able to show you a way to do that. So we're going to find t, and to find t, we're going to follow these steps. We're going to find v, and then the length of v, and then we're going to find t. So let's first find v. And after we find v, we're going to find the length of v. And then we're going to just find t, which is v over the length of v. Okay, that's not too bad. But we can see already how very nasty the problem is becoming. And I think what makes it nasty is this, excuse me, oh, one more. Okay, there we go. I think what makes it so nasty is this denominator. So what can we do about this denominator? Sometimes when something is nasty, I just give it a name. So I'm not going to take the whole denominator. I'm just going to take the inside, and I'm going to call t squared plus 64. I'm just going to call it u. And I like to do that when something's kind of ugly. So I'm calling u t squared plus 64. I keep in mind that u prime is 2t. All right, when I do that, then what does t look like? Well, then t has as its denominator u to the 1/2 power. And we're going to first verify that the length of t is equal to 1. Well, it looks a little bit prettier with u, and it's also easier to, I think, to work with. So I'm squaring the components and then adding the squares. And then keep in mind that t squared plus 64, that's what I'm calling u. And so then I have u over u, which is equal to 1. My next job is to find n. And to do that, I'll first find t prime, and then I'll find the length of t prime, and then I'll find n. All right, so this is where things really get dicey and where I'm very grateful for the use of u. I'm going to just look at the first component of t. I need to find that derivative, so I'm just using the quotient rule here. And I'm going to have to use the chain rule because u is a function of t, so u equals t squared plus 64. All right, so the derivative of t is equal to 1. The derivative of u to the 1/2 is 1/2 u to the negative 1/2 times 2t. Okay, so what I'd like to do is point out that this mess that's circled, that can be cleaned up, and I wouldn't go any farther until you clean it up. You've got 1/2, and you have a 2, and you have a t and another t, so you just end up with t squared times u to the negative 1/2. All right, so so this is what we have. And this type of, this last line tends to cause people problems and confusion as well. What I recommend you do is multiply the top and the bottom by u to the 1/2 power. And the reason why I'm choosing u to the 1/2 power is that my numerator has u to the negative 1/2 power. And rather than getting a common denominator and all that nonsense, it's easier just to obliterate the u to the negative 1/2 by just multiplying the top and the bottom by u to the 1/2. And so that's what I'm going to do. And the only other thing is you just got to be careful. So distribute the u to the 1/2, And notice that u to the 1/2 times u to the 1/2 is just u. And u to the negative 1/2 times u to the positive 1/2 is just u to the 0, which is 1. And so my very first component simplifies very nicely to 64 over u to the 3/2. Fortunately, the second component is not nearly as difficult. I just rewrite it and use the power rule and the chain rule, and this is what I get. All right, so then I've got the derivative of my first component, I have the derivative of my second component, and so finding t prime then is pretty easy. All right, so what about the length of t prime? Well, what's the definition of length? The square root of the sum of the squares. And u to the 3/2 squared is just u to the 3. And so that works out pretty nicely. And so I have two terms. Both terms have a denominator of u to the 3. So I can combine them, pull out a 64. And when I do that, I notice that I'm left with 64 plus t squared in the numerator. And that is u. So again, the u was just going to cancel with u to the 3, and I'll be left with 64 over u squared. And the square root of that is u over 8. Okay, so we've got t prime, we've got the length of t prime, and then it's pretty standard business finding n. Instead of dividing by 8 over u, I find it much easier to multiply by u over 8. And all sorts of nice cancellations occur. And I get 8 over u to the 1/2, t over u to the 1/2, and 0. All right, so that's my n. All right, now verify that its length is equal to 1. We're almost done here. The square root of the sum of the squares. Find the squares. Then I recognize that 64 plus t squared is equal to u. And so I have u over u, and the square root of that is equal to 1. And I would use this notation of u for showing that the dot product is equal to 0 as well. So let me know if this helps. It helps me anyhow, and I hope it's of use to you. All right, take care.